force anyone to listen to my videos on protection course prepared by engineer Sharif Hussain. The revenue metering panel is a mission-critical system, forming the commercial backbone of power systems by ensuring accurate, auditable, and legally defensible measurement of electrical energy. Revenue metering is governed by national grid codes, utility regulations, and international standards, making meter data legally binding and subject to audit and forensic verification. A revenue metering panel is a secure assembly comprising metering class transformers, certified energy meters, test facilities, communication interfaces, and sealing arrangements for high-accuracy energy measurement. These panels are designed for high-security metering, featuring networking, robust sealing, and seamless central time/Pacific time integration to prevent tampering and ensure data integrity. Their primary objectives include accurate billing and settlement, energy balancing, loss allocation, regulatory reporting, contractual compliance, and dispute resolution. Revenue metering panels are typically installed at generator grid connections, transmission substations, inter-utility tie lines, and bulk consumer incomers. The metering philosophy involves receiving scaled voltage and current signals from dedicated metering class CTs and VTs, which the revenue meter processes for highly accurate energy and demand values. Key metering quantities include active energy, reactive energy, apparent energy, maximum demand, instantaneous values, power factor, voltage unbalance, and frequency. Energy meters typically comply with class 0.2s or 0.5s accuracy, with associated CTs and VTs meeting matching or better accuracy classes under defined burdens. Metering CTs require low magnetizing current, high accuracy limit factor, minimal phase displacement, dedicated metering cores, and strict burden control. Redundancy and check metering involve main and check meters operating independently, often from separate CT/VT cores, allowing cross-verification and dispute investigation. Revenue meter types include static electronic meters, multifunction meters, and advanced smart meters supporting time of use, load profiling, and event recording. Time of use metering enables tariff differentiation, while load profiles support demand analysis, forecasting, and loss studies. Communication systems for metering panels include optical ports, RS, 485, Ethernet using DLMES/COSM, IEC 62056, Modbus, and DMP3 protocols. Factory testing ensures the reliability and accuracy of metering panels through secondary injection, meter replacement, and verification without interrupting supply. Panel construction and layout adhere to standards like IEC 61439, featuring segregation, EMC control, clear labeling, physical security, and provisions for sealing. Earthing and shielding follow a single-point earthing philosophy for metering circuits to prevent circulating currents and measurement errors. Time synchronization, often via GPS or NTP, ensures alignment for time-of-use billing, settlement periods, and reconciliation across utilities. Modern communication systems facilitate data flow to AMI and MDMS platforms for validation, estimation, editing, billing, and analytics. Data security and anti-tampering measures include physical seals, event logs, tamper detection, encrypted communication, access control, and audit trails. Cybersecurity compliance with IEC 62351 and utility policies protects billing data integrity through secure communications and intrusion detection. Commissioning and acceptance tests involve CT/VT polarity and ratio checks, burden verification, meter accuracy tests, communication validation, and sealing. Periodic testing and calibration, including scheduled recalibration and comparison of main and check meters, are crucial for forensic audits. Data validation and reconciliation ensure energy data is validated against system balances, historical trends, and redundant meters before settlement. Common errors like CT polarity reversal, incorrect ratios, excessive burden, poor earthing, clock drift, and communication loss can compromise accuracy. Noise resolution involves analyzing event logs, test blocks, and independent risk assessments to identify and mitigate nuisance tripping. The advantages of revenue metering panels include high financial accuracy, transparency, regulatory compliance, and reduced commercial risk. Limitations include high capital cost, strict installation discipline, and the requirement for highly skilled personnel. Applicable standards such as IEC 62052, IEC 62053, IEC 62056, IEEE C12 series, IEC 61439, and IEC 62351 guide the design and operation of these systems. Best engineering practices involve using dedicated cores, maintaining sealing integrity, ensuring redundancy, and performing regular audits. A practical utility case study involved a 220 kV interconnection revenue metering panel supporting settlement between two transmission operators. Revenue metering panels are legally critical systems requiring meticulous design, installation, and maintenance to ensure their integrity and performance. Follow me and share the video for engineering made simple.